Okay, this is lesson 2.3, use scatter plots to analyze data. So we did a scatter plot in our getting ready exercises. Now we're going to use it to analyze data. That note section is going to be kind of split into two parts. You can see off to the right, there's a little grid there. So within that grid, you might not want to start drawing right away. You might want to kind of see what I'm doing and then do it. But within that grid, we're going to draw a little graph, and then we're going to refer to that graph when we're doing our definitions. Okay?
Which graph?
Yeah, there's a very faint grid on the top right of page 11. And here we're going to write age, and here we're going to write height.
Still going on the graph?
So this should all fit. This is good. You can start yours now. This is how big your graph should be. And we're going to add some data here. And it doesn't really matter what your data looks like as long as it kind of follows this trend line that I'm drawing and just random dots, okay? And then we're going to throw one piece of data way over here. Okay? Yeah. Just a general kind of trend of a picture. And now on the left, we will take our notes. And the first note that we need when we're talking about any kind of graphs, in algebra, this comes up all the time. The word independent variable. And the independent variable is a variable that affects the value of another variable. So it's independent. It's not affected by anything else. It does the affecting. Okay, it changes another variable. That's contrasted with the dependent variable. And the dependent variable is then, of course, a variable that is affected by some other variable. And just a little note here. The independent variable is usually recorded along the horizontal axis. And the dependent variable is usually recorded along the vertical axis. So, if we were to look over at the grid that we drew with height versus age, or age versus height, which variable there, which category, height or age, is the independent variable? Age. So let's draw a little arrow here. Just independent variable. It's along the horizontal axis. Which one is the dependent? Height is dependent. Good. Okay. This little guy out here, anyone know what he's called? He is an outlier. An outlier. This is a measurement. If you are out of space, you can probably go to the bottom. Yep, that would be fine. If you're out of space, you can move to the bottom. Sorry, I should have given more space there. Outlier is a measurement that differs significantly from the rest of the data. It differs significantly from the rest of the data. So sometimes that happens. Something is very different than the rest of what you found out. For instance, you're measuring, I don't know, the age and height of cows, and all of a sudden you have a runt, right? Well, that's going to be an outlier. It's not going to fit in the rest of your data. If, because of the study that you're doing, this data is not relevant, you are allowed to kind of adjust and take it off and say, hey, this is an outlier. I'm not considering it in my overall data. But if it is relevant, like for instance, you were just calculating the average size of every cow in Canada, well then runt or giant, doesn't matter, they all need to be included, right? But it depends on what you're looking for. Let's just label this guy outlier. It's just an example of data that differs significantly from the rest of the data. Yeah?
For the test quiz, will we have to label a graph?
That's a good idea, sure. Yep. Okay, one more note at the bottom there is the word inference. Anyone know what an inference is?
Oh, like how it goes up? Like I like the pattern.
Okay, nice. So definitely identifying a pattern is part of that. Anyone know, like, what does it mean to infer something?
To show. Or to
No,
imply.
it's like to imply.
What I said.
So an inference is a conclusion. A conclusion based on reasoning and data. So just quickly, what can we infer from our little blue chart up here?
As you get older, you get taller.
As you get older, you get taller. Okay, basically. Yeah, whether you're talking about cows, you can make it up. It's just an example. Okay, there's a handful of notes. We are going to move on to example 1, which asks us to identify related variables. So the only terms that you really need to think about in this one are the dependent and independent variables. So we're going to read a little scenario or situation and determine which is the independent variable and which is the dependent variable. So A, the situation is this. Does the outdoor temperature affect the amount of fuel needed to heat a house? Now, you don't need to answer the question. You just need to identify the two variables. So what are our two variables in that situation? So fuel needed and outdoor temperature. Okay? Fuel needed and outdoor temperature. You can underline those if you'd like. And now you're thinking, which one depends on the other? Is the outside temperature going to change dependent on the amount of fuel I use inside? No. So independent is the temperature, right? And the amount of fuel used to heat the house depends on the outside temperature. Independent is outdoor temp. And dependent is fuel used or fuel needed. Good. B. Oh yeah, let's label them. So that means what would you... I guess let's do it this way. So often when we label something, when we're labeling a variable, we use the first letter of that variable. So a typical coordinate plane compares x on the horizontal axis and y on the vertical axis. But for instance, with age and height, we would have had maybe this is your a axis and this is your height axis, right? So what would our two axes be?
T and X.
So we might do T, capital T is usually temperature, and fuel needed, you could just do lowercase f. That works. You're just giving it a label that identifies it so that now when we talk about capital T, you know you're talking about the vertical axis, you're talking about the, sorry, I mixed it up. You're talking about the horizontal axis, the independent variable. Okay, B. Is there a relationship between people's age and their heights? What's independent and what's dependent? Okay. And labels? And someone else take on C. Does the amount of rain in a region depend on its latitude?
Latitude is independent. And the range.
And give it their labels.
I really like it.
Alright, that was not too difficult. I think you can do that. Just keep in mind that the concept that you just learned applies to all of math, all of data management. We're always going to typically put the dependent variable on the vertical axis and the independent variable on the horizontal axis. Looking at example 2, we're asked to draw a scatter plot. We're just going to do this. You have a little graph very faintly drawn there. So we have a skateboarder, starts from various points along a steep ramp and practices coasting to the bottom. This table lists the skateboarder's initial height above the bottom of the ramp and his speed at the bottom of the ramp. Do you think that we're going to have a strong correlation? Do you think these numbers are going to be pretty strongly connected?
No.
What relationship do you think you're going to find out?
The faster he goes, the higher he goes.
Careful, he's starting at a height and he's going down.
The higher he goes.
So the higher he starts, the faster he should be going when he gets to the bottom, right? That makes sense. So go ahead and draw your own grid there. Careful, right off the bat. Yep, but draw your own coordinate plane, like draw your own graph. But be careful where you start and end, and pay attention to the labels. So you're going on initial height, which we said is the x-axis, the horizontal axis. He's going from 2 is the lowest that he starts, and 5 is the highest that he starts. So you probably are going to just go from 0 to 6.
Which one would be the independent?
That's for you to think about.
Oh.
Start at
Does his speed depend on the height that he starts, or does the height that he starts depend on the speed that he is at the bottom?
The height. No. Speed.
Depends on height. So we're going to go with height here, and you go with speed as your vertical axis. And initial height goes from 0 to probably 6, so split this in half for 3. 1, 2, 4, 5, 6-ish. And the speed that he has goes up to 6.9, so let's say 8-ish maybe. 4, 6, 2. So your grid should look something like that. Of course, you have nice little lines there, so yours will be perfect. And now all we do is plug in that data. So you've already identified the independent variable. We've done A and the dependent variable. We've said that the speed that he is at the bottom of the ramp will depend on how high he started on the ramp. That should happen. And now we're making a scatter plot. So go ahead and plug in all your points. The first point is 2, 4.4. And again, yours will be perfect. Mine won't be. But I'll give you a few seconds to do that. Okay, your graph should look something like the one you see up there, except a lot neater. And A, I've just recorded that the independent variable was the height that he started on the ramp. The dependent variable is the speed that he's going at the bottom of the ramp. And now we skip down to C. Describe the relationship between the variables.
They all go up.
Raise your hand if you would like to describe the relationship between the variables. So make sure you're using both variables and saying how they're related. Yeah? Ronnie, what did you find?
Do you want to say that again, please?
Nope, it's number C. You can read it. What did we just graph? What did we just find out about the height and the speed?
It's the speed. Like how fast he's going.
Yep, what did we just find out about the relationship between the height that he starts
He goes higher.
and the speed that he is at the bottom?
He goes faster when he goes down.
So as he starts from a higher point,
Yep.
he's going faster at the bottom. Yeah? And we write that nicely. As the initial height increases, the skateboarder's speed at the bottom increases. Pattern of the data points is it's more of a curve than a straight line, but it's pretty straight as well. That's just another way of describing the relationship. So D, identify any outliers. Are there any outliers in the data?
Yeah, 4.0 and 4.5.
Yeah, this guy right here is definitely an outlier. Outlier. So D, let's learn about ordered pairs as well. The ordered pair, that means the independent and the dependent variable recorded as an ordered pair, and it was 4.0, 4.5. Okay, that's one of the ordered pairs from our data. That's our outlier. He's an outlier. Why?
Because his height and speed didn't match up, even though he went really fast, he goes fast at the bottom.
So yep, it doesn't seem to line up. The ordered pair 4.5 is separated from the rest of the data. We can clearly see that once we've plotted our data as we have. Can you think of any reason that might have happened?
Stick in the road.
Because his
Fell.
initial
Maybe he fell.
His ramp was lower.
It's all on the same ramp. Yep, that wouldn't change. It's all one skateboarder on one ramp, right? Otherwise it wouldn't be a fair test at all.
What does MS mean?
Meters per second, M/S. Learned about that in Unit 1 as well.
How can that 4.5 meters a second?
What else might have happened? So he probably didn't fall because he's still going pretty quickly, 4.5 meters per second.
I don't know.
Maybe he's
He did a cool trick.
Maybe
Tires? No, it couldn't.
Maybe he blew a tire.
No, like the
We'll never
it
know.
couldn't
So a
really
bearing
get
maybe?
greasy or something.
A
so
bearing
kinda
a bearing went?
We'll never know.
Maybe.
went slower.
Come on,
Maybe
keep on
just
coming.
stop midway to take a break.
Well, he's not stopping because he's still going 4.5 meters per second.
Maybe he
He
had
fell.
like he almost fell.
As he
Like
jumped.
he like.
Ah, maybe
fell.
he's like off balance, wobbly. Maybe he had to like drag his foot, something like that. Maybe he hit a stone and it got stuck on, in your grocery cart. Gets, stone under and you're dragging. Oh boy.
Car always was-
Anyway, maybe he dragged his foot. Anyway, it doesn't matter what you write. Your practice problems for that is the worksheet that you see on page 13. So you can complete that on a separate piece of paper. And again, if you're drawing a scatter plot or data of any sort, then make sure you're using graph paper, nice and neat. And then I will check your homeworks tomorrow, make sure we're all up to speed, and be ready to ask any questions that you have on the homework from 2.1, 2.2, and 2.3 tomorrow morning.